Now that you've learned way more than you ever possibly wanted to know about the Java ReentrantLock API, let's talk about how it gets applied in practice. And this is actually a pretty cool example because it comes straight out of ArrayBlockingQueue, which is a class that's in the Java class library itself, and a very useful class. So what is an ArrayBlockingQueue? An ArrayBlockingQueue is a bounded blocking FIFO queue. What the heck does that mean? It means that it does first in, first out protocol. So the one that's been in the longest is the one that's going to come out the first. It's bounded, meaning that it's limited to a certain number of elements that can be in the queue, and it's blocking, meaning that if the queue is empty, anybody who wants to take something from the queue will block, and if the queue is full, anybody who wants to put something in the queue will block. That's what blocking means. It implements something called abstract queue, or sorry, it extends something called abstract queue, and it implements the blocking queue interface. So it's a pretty interesting class. We're going to look here briefly at both the interface and implementation of portions of ArrayBlockingQueue. So let's see the stuff that's visible as well as some of the stuff that's not visible unless you watch this video. So Java's ReentrantLock was added to work around the limitations with Java built-in monitor objects, namely things like you can't interrupt them and they have a limited number of methods and features that they provide. So the ArrayBlockingQueue is going to use a ReentrantLock to guard access to all the shared mutable state. And this is the shared mutable state. So we keep track of the number of items that are in the queue. We keep track of where the next item will be taken from. We keep track of where the next item will be put. And we keep track of the number of elements in the queue. These fields here need not be defined as volatile. In fact, they absolutely should not be defined as volatile. And that's because the ReentrantLock is going to handle all of the atomicity, visibility, and ordering issues that would otherwise be problematic if multiple threads were reading and writing these fields. So we don't have to make them anything special. The lock and the proper use of the lock protocol will save our bacon and keep these things atomic, visible, and correctly ordered. So I'm going to show you an example here, and I love to do this. I'd like to show the code on one side and then visualize it on the other side. So we're going to take visualization of this. We're going to treat ArrayBlockingQueue as a critical section where we don't want these fields to be corrupted. That's the shared mutable state that will be guarded in the critical section. So we start out by making ourselves a bounded blocking queue that can store up to 10 items. So ArrayBlockingQueue will have up to 10 items, and we call it queue. Not very imaginative name, but whatever. Now, in thread T1, it's going to come along and it's going to call take on the queue. And because nobody else is holding the lock, nobody else is holding the ReentrantLock, then in this case, thread T1 will acquire the lock and it will enter the critical section. So what's going to happen in here is we're going to call lock interruptibly on the lock. And there's a whole bunch of mysticism about why it's done in the particular way it's done here, where we store the lock into a local variable. That was because of the way the compiler was implemented in early versions of Java. The optimization's long since been superseded by other stuff. So it doesn't have to be written this way, but that's the way the people wrote it. So I'm showing you the actual code, but don't think too much about that. So when lock interruptibly is called, that will increment the count by 1. So now the lock is held or acquired. So at that point, because of various things, take will not make any more progress because the queue is empty. But the count, that we've incremented the count by 1. So let's say another thread comes along and also calls take. So now we have 2 threads that call take. Well, what will happen here is this thread, T2, can't get into the critical section because the count is greater than 0. So the hold count is greater than 0, and this thread owns it. So this guy just has to park his little precious thread icon is parked here waiting to get into the critical section. Here's what the rest of the code looks like. I'm skipping like the interesting part, and the reason I'm skipping the interesting part is because that requires us to know what a condition object is, and we haven't talked about that yet in much detail. But at some point, after this guy is able to get an item from the queue, it will then finally unlock the lock, and that will decrement the hold count back to 0, and that means that this thread is now going to go away, and that lock will be released because the count is 0, and then this next, and and again, we use the finally block to make sure we always get out of the critical section no matter what might happen here. If there's an exception or a lock is interrupted, for example, we always release the lock. And now thread T2 can come in because the hold count is 0 and there is no owner of that particular reentrant lock anymore. Now, what I'm not showing you here, because like I said, we haven't talked about this in detail, when we get to the condition object part, I'll show you how the take method can magically wait until the count is greater than 0. Because there's no point in trying to take the item out of the queue if the count is 0, because there is no item to take out, right? So we'll talk more about that later, and you'll see how this works. It's really, really cool, but I'm going to skip that for now. When we do get to that point, you will see that all the code I show here that's kind of colored in red implements the so-called guarded suspension pattern and the monitor object pattern. And you can read about both of those things here. I wrote the monitor object pattern many years ago. It appears in the Posted 2 book, and but it's the concept's been around for ages. So anyway, that's basically the idea. We'll talk about that when the time comes. So that's the end of our discussion of applying Java reentrant lock in practice.